I'm sure we'll have a couple more people come in, but for the introduction, I am just going to begin. I'm Atwal Pinder, and I'm the recovery coordinator for the development program here in the Bahamas. Just as a little bit of background information, UNDP has been working in many areas in these now 15, 16 months since Dorian impacted Grand Bahama and the Abacos. But one of the most harsh realities post-Dorian was the destruction of such a large proportion of our buildings. And during the assessments that the Ministry of Public Works and others did post-hurricane, it became clear that the homes which had been built to code, the Bahamian building code, largely fared well. But that there was just a large proportion of our both businesses and homes that had not been built to our current national standards. We actually have here in the Bahamas one of the most progressive building codes in the region, but Dorian showed that there is this need to better assist individuals in how to meet those standards, which led the Ministry of Public Works to create the Guide to Housing Standards for the Bahamas, which I'll put in the link to that document here so you can download it. It's essentially a very easy to follow guide to the building code of the Bahamas, and we believe it will help homeowners and their contractors in building resilient homes. As part of that work as well, my fellow Bahamians here, Nick Sims and Eugene Thompson, were hired to lead our technical assistance centers in Grand Bahama and Abaco in conjunction with the DRA's small home repair program and the Rotary Clubs of the Bahamas. COVID, of course, has somewhat impacted our ability to conduct as many of the hands-on activities that we would have aimed to. And as a result, we've created this virtual Build Smarter webinar series where you're able to hear from the experts on certain parts of construction, rebuild projects, and then ask them your questions. As a little bit of introduction, Nick Sims is a licensed professional structural engineer with over 26 years of experience here in the Bahamas and 17 years in particular in Abaco. So he's very familiar with the construction over in Abaco. Eugene is an architectural technician and as someone who grew up in Grand Bahama, has over 30 years of experience working along the length and breadth of that island. So the way the sessions are going to work is that Nick and Eugene are going to begin with this presentation on the key points related to what this session is all about, which is the prescriptive method for in-place framing of roofs. And during the presentation, if you want to raise a question, please write it in the Q&A section here. It'll just make us, we can either get to it immediately during the presentation if it seems relevant, and we often do that, or we're also going to have a question and answer portion at the end of the presentation. Another thing that you can do, if you look in your sort of next to you, you'll have an icon which has a little hand. If you click on that, let me know that you do want to actually verbally ask your question. You'll be unmuted, and then you'll be able to verbally ask your question of either Eugene or Nick. Also, if you are on Facebook and watching, please do feel free, write your question there. I am monitoring that on a separate app, and I will be able to relay your questions to our presenters if you have any questions during that. I am going to say that I think we are ready to begin. I see we've got quite a few attendees at this point. So Nick, I'm just going to follow through with the agenda a little bit here. You'll see what it is and you can walk them through that, but please begin.
Okay, good evening all. Welcome one final time to the Build Smarter webinar series. Thank you for finding the time to take part in this training series. To reiterate, the intent of this training series is to provide an easy to follow, condensed presentation of the requirements of the Bahamas Building Code, the guidelines in the Guide to Housing Standards Manual that Atwal mentioned, as well as best building practices to help builders as well as homeowners in Abaco and Grand Bahama rebuild their homes so they are hurricane resilient. The Build Back Better Manual, another name for the Guide to the Housing Standards, was developed post-Dorian and is a Ministry of Works document drawn from the Bahamas Building Code. and developed in collaboration with the United Nations Development Program, the Jamaica Office, the University of the Bahamas, and the Disaster Reconstruction Authority. It is hoped from this training series, builders will have key steps in the building process reinforced for them, and perhaps learn some things that will improve their practice. Likewise, it is hoped that homeowners will become familiar with key concepts and steps of the building process, so they are more informed and aware of what is very likely the largest and most significant investment of their lives, and so therefore are allied with their builders in creating homes that are hurricane resilient. The training this afternoon is the fourth and final in the series focused on the construction of single-story homes in the Bahamas. And this afternoon, we will be looking at the prescriptive method for in-place hand framing of timber frame roofs for simple single-story homes. And just as a reminder, while it's always best practice to include a professional architect and engineer in the design of your home, this method will produce suitably hurricane resilient roofs for the majority of single-story homes. Next slide, please. So the process of framing the roof in place on site is really not overly complex, but it is information and detail saturated and is heavily reliant on the knowledge and experience of competent carpenters and builders. And so therefore requires much more time than available in this format of this training series to go through it on a step-by-step basis. This reliance on a wealth of knowledge and experience, coupled with the safety considerations associated with working at heights, means roof framing is best left to the builders and carpenters and should be avoided by novice do-it-yourselfers. For a thorough overview of the detailed process of in-place framing of timber roofs, we have a link here to a 1 hour long video that you guys will be able to go through at your leisure. And a note on that video, there are some slight tweaks to the roof framing as shown in the video, so that it accommodates our particular local requirements for framing for hurricane resilient roofs, but the fundamentals of the carpentry and the process is the same. For example, in the Bahamas, the correctness of connections between the components of the frame roof is especially important for achieving hurricane resilience. Next slide, please. So this afternoon, we will focus on those pertinent aspects and details presented in the Bahamas Building Code, the Build Back Better manual, as well as the legacy knowledge of experienced carpenters and builders. This information is worth repeating, will be useful for homeowners to be aware of as they work with their builder, as well as information that could be useful for builders in refreshing and perhaps improving their practice. This is a method that is not articulated in any one particular place or in detail in our building code, and much of it is based on the accumulation of knowledge over time on what works, and with which competent carpenters and builders will be intimately familiar with. If your builder is not familiar with this prescriptive method or with the information we present tonight, then seek one that is. All building plans submitted for permitting are required to include roof framing plans. The building control officer has the discretion and authority to require the submission of design computations on any aspect of any submitted drawings, including the roof design. However, for most home designs where the roofs fall within these qualifying parameters and reflect the accepted prescriptive method, the building control officer typically will not require any further information. And again, to reiterate, using a well-experienced, reputable architect and engineer to produce the drawings for your home will ensure a roof design that is safe, robust, and acceptable to the building control officer, and also helps avoid issues on site during the framing of the roof, which can prove disruptive to schedules and budgets. Next slide, please. So what are the building code guidelines that allow for the use of this historically accumulated prescriptive method? Well, number one, the top chords, also called the rafters, must be 2x6 members or larger. And as you can see in that diagram there, the top chord is called out. It's the sloping member that rises to a peak. That is the top chord or rafter. And number two, the bottom chord, also known as joist, must also be 2x6 or larger. And as you can see, it's called out there in the drawing again, 2x6 bottom chord. Next slide, please. The lumber must be pressure treated to guard against attack of termites and rot. And here we see in these two diagrams, when you get your lumber, you normally will be able to confirm that it's pressure treated by a tag that's stapled to the lumber somewhere, usually on the bottom. And it calls out the particular kind of chemical treatment. In this diagram, it's ACQ treatment that this piece of wood has been treated with. And on the right side there, you will see it's just a standard for how lumber is identified with certification stamps and treatment stamps. And the numbers are identified and all the identifying information is described here in this little blurb, so that when you can compare this to any lumber that you buy, so you know exactly what it is that you are purchasing for your house. Next slide, please. According to the code, for the typically available southern yellow pine lumber that is available at the local lumber yards, it requires that non-dense select structural grade or better is needed for in-place framing of roofs, and that satisfies the criteria in the code of 1200 psi in bending and tension parallel to grain. Those are technical terms, but that is the reference that requires the use of the particular grade called non-dense select structural grade or better. And those are the identifying stamps. This is a typical kind of stamp that you will see on lumber, so that you can identify what it is you're purchasing. Where you see the identification number 1 on the left, or number 2 on the right, number 2 prime, those are the grade markings of those particular pieces of lumber. So the lumber for framing of roofs, where it says number 1 or number 2 prime, should say select structural. Next slide, please. The code also requires that the rafters have a minimum of 4 inches of bearing at support wall. So what does that mean? So the diagram on the left is the bottom end of a rafter with what's called a bird seat cut, taking out of the rafter. And as you can see, there's a length of 4 inches there. That is where that rafter will sit down on the supporting wall below. The photo on the right shows this, where you see a series of 3 rafters sitting down on a wood plate. And there's the bird mouth cut, 4 inches deep, sitting down on the plate. So that is what the ministry is describing in the code. That bearing has to be 4 inches deep. Next slide, please. The rafters and joists must be anchored to the supporting walls. And there's a variety of ways to do this. The left diagram and the center diagram show 2 different ways of making this connection. On the left there is a typical, what we would recognize and call locally as a hurricane clip, attaching that rafter to the double wall plate below. In the middle is a different way of making that attachment, and you have a clip that is attached directly to the ceiling joist, to the double plate of the wall below. And the The code also requires that opposing rafters at the main ridge shall be anchored across the ridge. And that diagram on the right shows one particular way of doing that. As you can see, you have rafters coming from each direction, sloping up to the ridge to meet it, and they oppose each other directly. And that particular connection secures those rafters to that ridge. Next slide, please. Additionally, the following unwritten legacy parameters developed over time in making site frame roof trusses generally acceptable to the discretion of the building control officer are that the span of the roof must be less than 30 feet. So as you can see, the span is detailed underneath as minimum width 30 feet. That's actually incorrect. That should say maximum width 30 feet. Anything beyond 30 feet requires an engineer designed roof truss system. And the code also requires that the roof framing must be truss. So what does truss mean? Truss means that the shape of the roof is basically broken down into segmented, smaller triangular shapes. And as you can see, you have an overall triangular shape with the two rafters and the one ceiling joist. And then within that, you have the braces, the smaller braces, breaking up the interior shape into smaller triangular shapes. In this case, 1, 2, 3, 4, 5 triangular shapes. And why is that important? Because a triangle is a stable geometric shape and very efficient for resolving structural forces that occur from dead load, live load, as well as, most important for us, the wind loads, the heavy wind loads and hurricanes. Next slide, please. There's also some legacy parameters for the prescriptive method, and that is the maximum allowable spaces of trusses is 24 inches on center. So they can be less than that, but they can't be any further apart than that. Any further apart than that, and you're going to require, the building control officer is going to require a very specific engineering design. You're going to have to secure an engineer to deal with that, those trusses and that roof. Again, second point is the overhangs or the eaves. That's the section of the roof that goes past the exterior walls. Cannot be more than 24 inches long. Any longer than that, and again, you need particular engineering design to deal with that, and the building control officer will be looking for that. And the main ridge, lastly, the main ridge and the hip rafters must be 2x8s or greater, or at least one size greater than the common rafters. So where the previous requirement for a minimum of 2x6 common rafters are stipulated, that immediately requires that the main roof ridge and the hip rafters are 2x8s or greater. So you always want to stay one size ahead of what your common rafters are. Next slide, please. In the Build Back manual, it also recommends that hip roofs are used. And what is a hip roof? As you can see on that diagram on the left, you have two small houses, one with a hip roof on top and one with a gable roof on top of it. And you can see the difference in the gable roof. The wall actually extends up on the ends of the house to the ridge, whereas the hip roof slopes from all the walls up towards the ridge. And it's been determined from both calculations as well as real life data in field after hurricanes that hip roofs perform better resisting hurricane force winds than gable-ended roofs. Next slide, please. Additionally, calculations and in-field data know that the roof slope, a roof slope of between 6 to 12 to 10 to 12 perform better resisting hurricane force winds. So what does the roof slope mean, or the roof pitch? That's simply the angle that the rafter rises up to the ridge. It's just a carpentry nomenclature for describing what that angle is. And so that's what that top little diagram shows you. The roof pitch is the rise over the run. And what we have is a series of diagrams below running from 1 and 12 roof pitch to 12 and 12 roof pitch. And you want your roof pitch to be somewhere between 6 and 12 to 10 and 12. Those are the ideal slopes of the roof for maximizing resistance to hurricane force winds. Next slide, please. Similar to the design requirements for overhangs greater than 24 inches in depth, any porch or deck roof also requires particular design consideration. And the building control officer will be looking for this on your design drawings. This is important because these large overhanging roofs experience significant wind upload forces and must be carefully and properly designed in order to resist these wind loads. The Build Back Better manual also suggests that any porch or deck roofs are not attached to the main roof, so that should it fail during a hurricane, it will not damage the main roof as well. So what am I trying to describe there? If you go to the next slide, please. And here's a series of diagrams. The top two diagrams, here's a house with an large overhanging roof over the porch. But as you can see, that roof is part of the main house roof as well. So should that roof get damaged, the house is going to be exposed during a hurricane. Whereas the two diagrams below show a porch roof that is not connected to the main house roof. It's connected to the exterior wall of the house. And should that roof fail, it's not going to attempt to pull the main roof and damage the main roof as well. And hopefully the house remains intact and secure and safe for the occupants. Next slide, please. Proper design by a licensed structural engineer will ensure that the builder has all the information they need to correctly construct porch roofs so they do not fail. Now, while we are focusing on site frame roofs, it must be mentioned that another option, no matter the roof size or configuration, is the design and supply of prefabricated trusses, which are trusses that are built off-site by a truss manufacturer. That's their business. There are businesses that deal specifically with just building roof trusses. And depending on the situation and any of the challenges a particular homeowner might be facing, this could be a viable choice for the construction of your roof. The homeowner should have a conversation about this roof building option with a competent, well-referenced builder. And if they have one or know one, or with a professional in the construction business, such as a licensed engineer and architect, so that they can understand the pros and cons of the choices available to them and then make an informed decision. This option requires a structural engineering design of the trusses, and after fabrication of the trusses at the manufacturer, they are then transported to site, typically on a large flatbed truck, and then hoisted into position on top of your house using a crane. Okay, next slide, please. And this is Eugene.
Good evening, everybody. The materials, we will talk about quality control considerations, the materials. We will go through the various materials that will be needed for building a roof, including the various quality control checks on the materials for ensuring code compliant, sound, and appropriate materials are used. Framing lumber. As already mentioned by Nick, all framing lumber should be pressure treated to guard against termite and rot, and be of grade non-dense, select, structural southern yellow pine or better. A different species or grade of wood will require an engineering design, and calculations may be required with the submittal of the drawings to the building control officer. So here you have a picture showing the stamp that will be on every piece of lumber and you would need to know exactly what you're looking for. Southern yellow pine, number 1, kiln dried. If possible, it is best to hand select all your framing lumber at the lumber yard at the time of purchase. You want to select the straightest pieces that have little to no defects on them. This is time consuming, but is a critical step for ensuring your roof is being built with quality lumber. Next, let's look at our plywood. Plywood, all roof plywood must be sheeting rated and a minimum of 5/8 inch thickness. Plywood must be exterior grade classification if permanently exposed to outdoor locations, which means it is capable of withstanding repeated wetting and drying cycles or long-term exposure to weather. The typical CDX plywood available at hardware stores is not exterior grade, but rather exposure 1 grade, which means it is made with adhesive that is moisture resistant, and it can withstand short lengths of exposure to moisture. The length of time that plywood is exposed to moisture during an efficiently run construction project through to completion is considered to qualify for use of CDX plywood. However, for the sake of better quality, peace of mind, and the common occurrence of lengthy, inefficient construction activity within a very humid climate that often has heavy rains, then exterior grade plywood should be considered for the wall sheeting.
Well, the roof, yeah, I should say
The,
roof. Yeah.
the roof, yeah, sorry, we're considering roof at this time. So we should also consider exterior grade for the roof, especially if it will be exposed for a long period of time. So ideally, the plywood should also be pressure treated to guard against termite attack. Ensure the plywood bears the stamp of the approved certifying agent. For the Bahamas Building Code, this is the American Plywood Association, APA, and the applicable stamp for exterior grade sheeting rated plywood that is pressure treated as well will look like this. On the right-hand side, you will see APA for the American Plywood Associated. It shows the rating, it shows the size, it shows the thickness. And so look for this on any plywood before you purchase to make sure that you get the correct one for your application. Next slide. Let's talk about nails, bolts, screws, and metal connectors. Nails, bolts, screws, and metal connectors are to be hot dipped galvanized, HDG, or best to use, if it can be afforded, is stainless steel grade 316. This ensures suitable protection against the always present conditions for corrosion on small islands, as well as these are the specified types of materials that are compatible with the chemicals and metals used in the process of manufacturing pressure-treated lumber and plywood, such that there are no adverse reactions that would occur. Of course, nails, bolts, and metal connectors will be in contact with or embedded within pressure-treated framing lumber and plywood sheeting. Ensure as well the proper gauge and length nail is used for each connection joint and type of metal connector. Each connection joint and metal connector requires a specific nail to achieve its design rated strength. Use of the incorrect nail can reduce the strength rating and thus effectiveness of metal connectors, at times to the extent of being dangerous to the occupant of the dwelling. A very common historical error made by builders is using the incorrect nail specification for a given metal connector. For example, using 8-penny nails for Simpson's H2.5 Hurricane clip instead of the 10-penny 1.5-inch nail that Simpson specifies for this clip. Let's move on. Use of ring shank nails is recommended for the roof framing and required for nailing on roofing plywood sheeting due to its greater holding power. Ring shanked nails are those that have ribbing along the length of its shank. And here again, we have illustration. On the left is the ring shanked nails. You see the rings going around it. On the right hand, to the left is the smooth shank common nail, and it is very common. In the center, we have the spiral shank nail, which is a stronger option. And then to the right, we have the ring shank nail, which is the strongest option. Next slide. Critical connections, trusses. We'll first look at top of rafters at ridge board. Each rafter is nailed off to the ridge board with eight 16-penny nails. Install hurricane straps across the tops of rafter pairs at the ridge board. And there's an illustration to show that. We would see the ridge board, then we would see the two trusses coming in, the two rafters coming in, and we see the strap going across the ridge board and nailed to each of the rafters. That is the proper way for this critical connection to be achieved. Next slide. Webs to cords. Webs must engage full depth of cords. Nail off with 4 16-penny nails. Again, the illustration shows the webs, and Nick showed us earlier the triangles are formed. So the webs would be the vertical pieces going up, and they have to be nailed off with 4 16-penny nails.
So you see, just before we move on, in that photo, it's really interesting. The webs in the foreground, the webs nearest to us, you can see they only engage that bottom cord, maybe half depth of that bottom cord.
Right.
Whereas further away, some of the webs you can see have fully engaging the full depth of the bottom cord. So in this one photo, you see examples of how it should be done versus how it should not be done. So it's a very instructive photo there.
Good point. Okay, next slide. Webs to cords. Clinch all nails perpendicular to the grain of the cord, as shown here. Next slide. Okay, that would have been an illustration of the proper way to drive the nail perpendicular to the grain of the cord.
So what would happen if you could go back to that real quick, if I could add something? So the gentleman there is driving in the nail. What will happen with the 3.5 inch long 16-penny nail? That's going to drive all the way through the web member, through the bottom cord, and a bit of it will come out on the other side of that bottom cord. So it will protrude on the back side. So to increase the holding power of that nail, what clinching means is to use your hammer to bend the nail over again and knock down that edge so it lays against the bottom cord. In other words, the nail is also clamping down, clamping those two members together. So it's almost impossible to pull that nail back out. So it acts as a clamp. That's what clinching means. The nails also serve a clamping purpose.
Thank you. Okay, you would have also seen in a diagram that the bottom cord is spliced. So let's look at splicing of bottom cords. The span of the roof often results in a splice of the bottom cord, as common lumber lengths beyond 18 feet on island are few and tend to be quite expensive. These lumber lengths, when in stock, are typically of poor quality. For example, they're not straight. So the bottom cord must be built with 2 lengths of lumber that are shorter than the span. Another example, if you have a 26-foot span, then you would use 2 16-foot lengths of lumber, and they are overlapped at the center of the truss span. Again, consult a structural engineer for necessary overlap or splice length and connections as required by your particular house and truss layout. Next. Now we look at truss to bearing wall connections. There are multiple options. You see the H2A installation, and you will notice the strap, sorry. The strap in the H2A connects to the post, also to the beam and to the rafter. And then we have number three is the TSP installation. And you will note the particular slope of the connector again in connection with the rafters. You have the H2A installation, number 4. And then we have the H2A 2.5 T installation. And again, it's important to note that the nails go through both of the members. Okay, slide 30. The most common method is to install 2 hurricane clips, typically H2.5 or H2.5A by the manufacturer Simpson's or the equivalent from other manufacturers. The clips should be installed on each side of each truss. This usually results in one clip attached to the bottom cord or the rafter, and the other clip being attached to the joist, the bottom cord of the joist. The rafter and joist should be securely nailed to each other as well, with number 16 penny nails, minimum. 6 number 16 penny nails. And they will be clinched again perpendicular to the grain. And it's illustrated once again for you. So we see instances of straps to the studs, and then we see instance of the clips being nailed to both sides of the truss, one to the rafter and one to the joist. Do not attach hurricane clips opposite each other on either side of a rafter, as in this video. The clips are attached to the rafter with 5 nails. These nails will compete with each other and riddle the wood if 2 clips are installed, thus reducing its integrity. Instead, locate the clips diagonally opposed to each other. Can we see that one more time, please? Okay. Thank you. Next, plywood to trusses. Install blocking between trusses at all plywood seam locations. Stagger plywood so that vertical joints do not line up. Recommend the use of construction grade glue in addition to nails. Plywood edges along perimeter of roof, the ridge, and any hips and valleys should be nailed at 4 inches on center with 8 penny, which are 2.5 inch long, ring shank nails. Plywood elsewhere is nailed at 6 inch on center. And again, it must be 8 penny ring shank nails, which would be 2.5 inches long. Here is another slide to show that. Move on, please. So we see the staggered application of the plywood decking. We also see the blocking that is being added to every splice in the plywood at all joints. And again, we are considering hurricane resiliency in our construction. So this is what you really, really need to pay attention to so that everything is fastened properly and you'll be safe and comfortable in your home. Thank you. Next slide. So this slide shows the underlayment As per specification, today everybody knows Grace Ice and Water Shield. That is placed on your plywood, which has been properly nailed, as we just discussed. And on top of the Grace Ice and Water Shield, or the underlayment, would be the asphalt shingles, again, per specification. The framing is seen over to the right. You see that there's 2x6 timber treated ridge, which we discussed already. The plywood is 5/8 plywood. The rafters are 2x6 timber treated rafters. And we spoke about the spacing of the nails, which should be 6 inches on center. And the top plate minimum is a 3x6 timber treated top plate. And of course, we have a fascia board, which would be 1x8 timber treated fascia. And these would all sit on a concrete block wall or a timber stud frame, as per specification. So hopefully you've been able to glean something from our instructions and details today, and we'll turn it back over to Etwal for the next step.
Thank you, Nick, Eugene, both of you so much for all of your insights, of course. For everybody who is an attendee, Caldwell Pratt, I apologize that I missed your hand being raised earlier, but you're now able to talk if you would choose to. If you prefer to type, you can feel free to, but you will be able to ask any questions that you would like now if you want. Anybody else, please just either raise your virtual hand or write a question in the Q&A section.
I see Darius mentions that something is upside down. I'm not sure at what point he mentioned that.
I don't have that in mind. So you're seeing that and I am not. Sorry.
To the panelists.
There we go. This is upside down. Here, Darius, I'm gonna, if you choose Darius, let us know what you mean.
Okay, basically on the last slide, you had the laps of the underlayment and the shingles the wrong way around.
The slide that's up now?
Yes, those shingles should have been to the bottom and the underlayment to the top, so the laps would be in the correct way, so that the rain coming down the side of the pitch of the roof doesn't get trapped. And then those shingles should have started from the bottom, not the top.
Absolutely correct.
Yeah.
Yeah.
Yeah, the rolled up pieces of paper are definitely incorrect.
Yeah, it's not that's not a very good diagram for showing the underlayment on the shingles. Really, the focus of this is
basically you can't person just turned it 180 degrees.
Yeah. Yeah.
It just needs the plywood to turn it 100.
Yeah. You work from the bottom up. You don't work from the top down for roofs. Absolutely correct. Yeah.
That is great. I was a little concerned when you were saying it was upside down.
Yeah.
Was it fully understood? And thank you for pointing that out.
Yeah.
Mr. Pratt, I still see that you have your hand up. If you do want to ask a question, please let us know. Or anybody else. I am actually just gonna let everybody talk, and then if anybody wants to ask a question, you can. Dan, please ask away.
Yeah, quick question. You did a great job in this, by the way, and I see that you're showing us how to anchor to the top wood plate. I've been out there with Hart 911 quite a bit, and we're coming across a lot of concrete walls, cinder block walls. And how would you recommend how to fasten the roof rafters down to that application?
That's really not recommended in the code. So there is a section that speaks to that. I would have to go and refresh my memory right now, but the standard typical details that are associated with the prescriptive method for concrete walls require a 3x6 timber plate that is mounted to the reinforced concrete beam that would be on top of a concrete wall, a concrete block wall.
Right. So my question would be, how do you fasten the pressure treated wood to the concrete wall?
That is with using 5/8 by 10-inch long anchor bolts,
Okay.
36-inch center spacing, centered in that plate, bolting that plate down to the concrete beam. So when you go to pour your concrete beam, you want to have those bolts in place. You're going to cast those bolts into the beam when you pour your concrete beam.
Gotcha. Thank you.
Right.
Thanks, Dan. Godfrey, I have you next, Mr. Wilson. Mr. Wilson, are you there?
I don't know how to do it.
If not, I've got Rush and Selena. Either of you who have a question? Anybody?
No, no questions. Thank you.
Okay. Selena, any questions?
No questions. Thank you.
Okay, I am looking into the Q&A to see if anybody was more hesitant and actually typed it in, but we don't have any written ones. Does anybody else have a question about the roof framing? Okay, well then, Nick and Eugene, thank you as always for providing your insights and your expertise. I had seen that Mr. Delancey was on. Thank you so much, sir, for being a part of this. And wondered if you had any thoughts or comments that you wanted to provide.
No questions.
Okay. Well then, thank you all of you as participants for being a part of this. I did put the link into our chat, which has the Guide to Housing Standards, which is the document the Ministry of Public Works did in conjunction with the University of the Bahamas and UNDP, Multi-Country Office from Jamaica. Also, we are continuing our series of Build Smarter webinar trainings. If you follow us, honestly, it's just easy if you follow us on Facebook to keep up to date. But I also do put out an email listing. So if you're interested on being on that email list, you can just email me directly. I am etoile.pender@undp.org. That is my pocket talking to you. Apologies for that. But on that note, I'm going to bid everybody a good night.
Good night.
Okay.
Thank you, everybody.
Thank you.
Thank you. Good night.